I welcome you all for the video lecture on review of linear algebra for machine learning. I have prepared a series of video lectures on machine learning. This is mainly to support the students, those who have taken artificial intelligence and data science as their branch of study in BTech. In this particular video lecture, we will be discussing what is linear algebra and what is the contribution of linear algebra in machine learning. Let me begin the lecture by defining what is linear algebra first of all. It is a branch of mathematics which concerns linear equations. The linear equation is of the form a1x1 plus a2x2 up to an x1 which is equal to b. This we call it as linear transformation of x. In general, vector notation we use to represent as a transpose x is equal to b. So this linear algebra is fundamental in geometry to define objects such as lines, planes and rotations and all. Now let us try to understand why do we need to study this linear algebra in machine learning. To make you understand the use of linear algebra in machine learning, I have chosen a simple example. Here I have collected person's height and weight, which I represented in the table. Now, I'm going to represent this height and weight using some vector space notation. So why do I choose vector space? If I look at the data, it contains only magnitude. Or then why not I use only the scalar representation to represent them? Why do I go for vector representation? Because using vector, we can bring the or we can show the relationship among these two features. We know that the vector will contain both magnitude and direction. Here in machine learning, direction means not the usual direction we see in geometry. Here it represents the relationship between the features that will be represented as direction. That I mean, it's not a direction actually; it is a relationship. Again, to make you understand, I have drawn the graph with the help of these two attributes. You see, in the x-axis I represented weight and the y-axis I represented height. Here, that line drawn represents for the increase in height how the weight varies. Right. So here, this line represents the relationship between height and weight, not the direction. Right. So because of this, we are using vector notation to represent the features of the data set. Then what is the use of linear algebra? Actually, with the help of linear algebra, we can do linear transformations. So by doing linear transformations, we are going to analyze various relationship between among the data. That is why you are using linear algebra in machine learning. So let us study the basic concepts related to linear algebra in our further slides. In general, we will be using different kinds of data such as images, text and user preferences, etc. This data will be organized using vector representation, where vector is a one-dimensional array of elements. It has both magnitude and direction, as I said already. A feature vector is a vector whose entries represents features of some object. A vector space containing them is called feature space, and these are the terms we will be using in machine learning. That is why we are seeing here. And essential for understanding machine learning algorithms is how do we convert input vectors into output by linear transformation. Here this shows how the image is represented using vector. You see the pixel intensities are represented in matrix representation. Later this matrix is converted into vector. Suppose if you are working on semantic analysis, you will be analyzing how much time that particular word occurs. Here in the simple example, we represented how many times that word dog appears in different documents. So this is how the data will be represented in vector representation. Suppose if you are doing analysis on the rating of movie, how do you represent the data? Here in the simple diagram, you see user 1, the vector representation of user 1 says that how many times the user interacts with the particular movie. Each and every column in the vector space represents the different movies. Suppose if the user interacted with the movie, it will be 1, otherwise it will be 0. Similarly, here at the right hand side it represents the ratings. Instead of whether he interacted or not. Here it represents ratings. The ratings goes from number 0 to 5. Where here also the column represents the different movies. How much ratings the user given to a particular movie is represented in vector representation here. The simple way to represent non-numerical data is to use one-hot encoding. Here I have chosen four different words. The diagram shows how these four different words are encoded using vector, one-hot encoding. Right. Apple is equal to 100 means, I mean, the first space is reserved for apple, the second cell is reserved for cat. If it is present, it will be 1, otherwise it will be 0. This is how we will be representing data using one-hot encoding. But the drawback is it occupies larger volume of space. Now we are going to see the different operations we perform on linear algebra. To start that, we are going to begin with defining what is scalar and what is vector, what is matrices and tensor, and we will be discussing different operations like how do we multiply matrices and vector, how about the identity and inverse matrices and all. Scalar is a single number. It will be represented using a simple lowercase italic alphabet. It can take either real valued numbers or integer values. Vector is a one-dimensional array of numbers. Each number is identified by an index. It will be written using lowercase bold alphabet. Here I have represented how the column vector will be and how the row vector will be. Everyone knows what is matrices. It is a two-dimensional array of numbers. Each element is identified with the help of two indices. Normally, it is denoted by the bold alphabet letter. It contains both row and column. We can consider a vector as a special case of matrix. Vector can be said as a matrix with single column. A scalar is a matrix with only one element. What is tensors? Tensor is an array of numbers that may be zero dimension. If tensor is zero dimension, it is called as scalar. If tensor is of one dimension, then we call it as vector. If it has two dimension, we call it as matrix, and it contains more dimensions also. Normally, this tensor also is represented with the help of bold capital alphabet. This diagram shows different dimensions of a tensor. One dimension tensor means it is a vector. Two dimension means it is a matrices, whereas n dimensional tensor will be represented like this. This slide shows some of the NumPy library in Python for tensors. You just see x dot ndim represents what is the dimension of the tensor, with the help of which we can easily know what is the dimension we use. These are some of the special matrices we study. Diagonal matrix means the diagonal position elements will be there. In the non-diagonal position, the element will be 0. Whereas in case of identity matrix, the diagonal position value will be 1. Whereas in other position, the value will be 0. Upper triangular matrix means above the diagonal position, and above of diagonal position we will be having values, below we will be having 0 value, whereas the inverse one is lower triangular matrix. Symmetric matrix means that if we interchange row and column, the matrix will remain same. So, and these are the simple matrix operations we perform. We can perform a transpose of a matrix, matrix addition, scalar multiplication, matrix multiplication. We know how to perform matrix addition. This already you would have studied in your earlier classes. So let me skip explanation for this slides. You please go through the slides by yourself and try to understand by yourself. This is a slide which corresponds to matrix multiplication, and here the slide shows how do we perform transpose of a matrix. So this is the reference site which will give you some good insight on why do we use vector in linear algebra. Thank you all for watching the video.